All right, good morning, good morning. Let's do some more linear equations. So let's just jump right in. This is, again, Algebra 1 review. There's not anything new today. So hopefully these play-posit questions are going to be easy. So point slope form, this is somewhere in your brain. You had it memorized at one point. You just need to pull it back from the back of your brain to the front of your brain. So this is if we're given a point x1, y1, and a slope. Oh, pause me and write all that stuff down, including the example. Okay, so we substitute in for the y1 and the x1 and the m, and we leave the y and the x alone because we're used to seeing equations with y's and x's, right? We're going to do examples of this, so don't worry. I just want to point out that this is exactly the same as the slope equation. So if I take this point slope form and I divide both sides to get the m by itself, so then that whole thing cancels out. Remember, we can cancel because it's attached with multiplication. I end up with m equals y minus y1 over x minus x1. And isn't that exactly the same as the slope equation? Like, we just write it a little bit differently. But it means the exact same thing. It's just saying there's a y value and a different y value, and we're subtracting them. And there's a y value and an x value and a different x value, and we're subtracting them. So that's all that means. The subscripts are just differentiating between different points on a line. Okay? All right, so write an equation of the line in slope-intercept form. So this might be deceiving here where it says in slope-intercept form. That's how they want the answer. That is not telling you which form to use. So if you look here, you'll see they're giving me a point and a slope. So guess what? I'm going to use point slope form. So they named these this way for a reason. It's called point slope form because we use it when we're given a point and a slope. So I'm going to write the equation. The more often you write this equation, the easier it's going to be to pull it from the back of your brain like I mentioned. Or if somehow you manage to pass Algebra 1 without memorizing that, then it will help you to memorize it. So remember, the point that we're given is called x1, y1, and the m is the slope. So I'm going to put the y1 in place of y1. I'm going to put the x1 in place of x, and I'm going to put the slope in place of the slope, and everything else stays the same. So y minus the y1 equals m times x minus the x1. And then we all know minus a negative. Oh, and everybody's groaning right now because they have to deal with a 1/2. It's okay. We'll get through it. Promise. So I'm going to distribute. So once I plug in, I'm going to distribute. So 1/2 times x is easy. It's just 1/2 x. And 1/2 times 3 is just 3 over 2. Remember, when we're multiplying, we multiply straight across. It's a positive times a negative. And then I need to solve for y. So I'm going to subtract 1 from both sides, but I'm going to do it in what might look like a funny way. Watch. I'm going to subtract 1, and I'm going to subtract 1. Do you agree that I did the same thing on both sides, even though it looks different? I am subtracting 1 from both sides. This way I can cross that out, get the y by itself, and now these have a common denominator so that I can actually smush them together. So we're putting the 1 underneath its like term. I don't want to write it under the x because I can't combine those. And then now this has a common denominator, so I have 3 halves and 2 halves, which make 5 halves. And they're all negative. Okay? Okay, this one is a little bit different. They're giving me 2 points, and we don't have a point-point form. We haven't learned a point-point form. We've learned point slope and slope intercept. What do they all have in common? point slope and slope intercept both have something in common. What is it? Okay, so let me write that down really fast. All right. They have the slope. We need the slope. And I'm given 2 points here so I can find the slope using the slope formula. So I label this x1, y1 and x2, y2, and the order doesn't matter. If you want to call the first one x2, y2, you can do that. As long as the one subscript stays with the x and y together and the 2 subscript stays with the x and the y together. So I'm going to go the y2 minus the y1 over the x2 minus the x1. And I'm going to simplify that. And I'm going to get -2. Now I have a point and a slope. I actually have 2 points and a slope. So I get to choose. If we were in class, I would have half of the class write the equation using the first point, and the other half of the class write the equation using the second point, and then we would compare answers and they would be the same. I would love it if you guys would do that on your own, but I don't want to make this video longer than it needs to be, so I'm not going to do it, okay? So I'm going to use the x1, y1 since it's already labeled to plug into this. Again, the more you write this equation, the easier it's going to be to memorize, okay? So I'm going to go y minus y1, oh that's nice, equals the m we just found times x minus x1, okay? Y minus y1 equals m down here times x minus x1. Well, anything minus 0 is just that thing. And then distributing, and I'm done because the y is already by itself. So I'm distributing there. So this one kind of has a step 0 added. So we're going to go through steps 1, 2, and 3, but first we need to find the slope. So we found the slope. We plugged in, we distributed, and step 3 was already done for us. Okay? All right, so take a second, pause me, and write all this down. All right, so standard form is the third form of a line that we typically look at. Ax plus by equals c. A, b, and c are integers, and a has to be greater than 0. So first thing is, what are integers? They're positive and negative whole numbers. Okay, positive and negative whole numbers. So like -3, -2, -1, 0, 1, 2, 3, and so on. Okay, and then what does it mean for a to be greater than 0? It means that a is positive. Greater than 0 means positive. Think about a number line. So the first one's pretty easy. Standard form, I want to get the x and the y on the same side. So all I have to do is, excuse me, subtract 3x from both sides. These are not like terms, so I can't combine them. I'm literally just going to write what I have. I have a -3x and a positive y. And then I have the equal sign. That goes away, and -7. If you write this on a quiz or a test, you're only going to get about half credit for this problem. This problem is 2 steps, and you've only done 1 of them. So what am I missing? A has to be positive. How do I do that? I'm just going to multiply everything by a negative. I'm going to distribute a -1 to the entire equation, and I end up with positive, negative, positive, instead of negative, positive, negative. Okay? So what's the first step that I'm going to do on this one? Same thing as the other one. I want to get the x and the y on the same side. So maybe we write steps for these. Get x and y on same side of equal sign. Okay? So I'm going to subtract 1/2 x to move it over. And again, these are not like terms. I can't combine them, so I literally just write what I have. I have a -1/2 x and a positive y, and I want to write them in this order. Don't put the y first because you're going to give yourself an extra step. Then I have the equal sign. That goes away. 4, but I'm still not okay here. A has to be, A, B, and C have to be integers, positive and negative whole numbers. This is not an integer. Whole numbers are 1, 2, 3, 4, 5, 6, 7, etc. And I need this, we can't have fractions. Also, A has to be positive. So I need to multiply everything by, I didn't give myself enough space, -2. Hopefully you can see that. Yeah, I think you can. The negative and the negative are going to turn it into positive. And then if I have 2 times 1/2, that's going to turn into an integer. So I need to always multiply by whatever's in the denominator to get rid of the fraction. Okay, so I'm going to put here check conditions. That means these right here. Okay, these are the conditions I'm talking about. And then just as a little side note, if there's a fraction, multiply by whatever's in the denominator to get rid of the fraction. Okay? The numerator can stay. It's the denominator that we want to get rid of. And then watch out for negatives. For A. A is not allowed to be negative. Okay? So if I distribute this -2, we already said this is going to become 1. And then I'm going to distribute the -2 to the y. Oops, I didn't write a negative over here. Hopefully you caught that. I'm multiplying both sides by the same thing because that's what we're allowed to do, right? So then the right side becomes -8. So everything else is allowed to be negative, just not A. Okay? All right, I hope that was okay.